Hello there. My name is Yemi Akimbamijo, the Executive Director of the Forum for Agricultural Research in Africa, based out here in Accra, Ghana. It is indeed a great pleasure for me to be able to give a keynote presentation at this conference, the African Conference on Precision Agriculture. And the subject of my discussion this morning is based around precision agriculture for smallholders. What are the imperatives for Africa's agriculture? To be able to guide my thoughts this morning, my discussion is outlined on this slide as presented in 6 points. First, looking at some information about the Forum for Agricultural Research in Africa. Then I will speak a little bit to the subject of precision agriculture. What are the implications for us in Africa? And then I will go on to look at African agriculture and smallholder farmers. What prospects does precision agriculture hold for our small, medium enterprise-based agricultural production systems? And then I'll be looking at opportunities for smallholder farmers, challenges to precision agriculture in the African context, and then I will conclude with a few remarks. So, for starters, I would just like to say that the Forum for Agricultural Research in Africa, FARA, is a composite body, and it is also the apex institution for agricultural research on the continent. It is composed, and the institutions are on the bottom right of the slide, of Koraf in the western part of the continent, Asareka in the eastern part of the continent, Kadesa in the southern, and Nasro in the northern. We're also the technical arm of the African Union Commission on matters around agricultural research and development, and we do the same for the African Union Development Agency. In terms of our impact pathway, FARA is guided by a 3-tier hierarchical order by which we look first at the functions of FARA, that then leads us into the 3 areas of raising productivity, of improving agro-industry and competitiveness along the value chain, and then building resilience. And hopefully this leads to the 4 elements of food security, income and job creation, increased resilience, and improved natural resource management. Now, coming down to the subject of precision agriculture, as an introduction, precision agriculture in itself is what I describe as an intensive geospatial IT-driven approach to be able to manage farms that are based on our knowledge of intra and interfield variations of soil and crop physiology in time and space. So this is a very complex scenario, but with the different tools that are on hand, managing geospatial information using GPS, satellite imageries, drones, combining all of these and using the local interventions with on-the-ground uses of mechanizations, of machines rather, pesticide application, fertilizer application, and all of this in a way that leads towards improved efficiency and effectiveness of resources. Precision agriculture also looks at how the phytogeomorphology influences productivity, how the terrain features would affect plant growth. And this is where the deployment of drone technologies, and in some other descriptions I have spoken around drones for development, how they help to improve the efficiency of resource use. So looking at the scenario where we are looking at precision agriculture in the context of the small farmers, as you know, that the production system in Africa is largely underpinned by smallholder farming operators, where the average land holding is normally less than 2 hectares per household. So in that context, we'll be discussing the roles and the functions of and the opportunities, of course, of precision agriculture in this system. So to start with, I must state that Africa has enormous potentials within the continent. And in that respect, when you look at the resources on the continent, we have over 70% of the arable land on the planet is still in Africa, over 80% of the fresh water, and we have a burgeoning population of 60% youth consisting of the total population. In terms of the resources, the main source of livelihood for 70% of the population is agriculture. And this accounts for anywhere between 30 and 40% of the gross domestic product in most of the 54 or 55 member states of the continent. As I said before, the agriculture in Africa is smallholder based. The holdings are very small compared to what obtains in the Western world. Most of the farmers are subsistence. In other words, they grow what they eat, and commercialization is still at a very rudimentary stage. And then we have a diverse system where you have a lot of mixed farming, a mixture of diverse staple crops with livestock productivity. And on the picture you have on your slide on the screen is just a snapshot of what we call the mosaic of a farming system, where you see the household in the center, and is then dotted around by all different forms of field that provide the household with their staples. So the last point is that the agricultural landscape in Africa is largely rain-fed. So this is a big issue because it lends the production system to huge variabilities and vulnerabilities of climate change. And as you can see, the picture on the right rather, you see how parched the land is, and these are some of the things that lend to the environmental degradation that we have come to know so well. The sixth point is that all of these together converges on the low productivity that is the bane of Africa's food production system. So we need to increase the production, and one, by increasing the spatial area that is under cultivation. But of course, we also have a system that is so labor intensive because everything is done manually. Mechanization is still at a very, very rudimentary stage, although there are some glimmer of hope. But as we speak, mechanization is still not the way it should be. Then we have underutilization of STI, of science, technology, and innovation. A lot of farmers are still planting grains, not seeds. A lot of farmers are still using hoes and cutlasses, and that's not how you're going to feed 1 billion people. And that explains the reason why, despite the huge resources, we are actually living in a paradox. The resources are overwhelming, but we fail to be able to catalyze the resources and transform them into commercializable products. So, however, what obtains is that when you look at the situation in Africa and you look at the situation in the global scale, we find that agribusiness actually accounts for about 3/4 of the value added in the value chain. And when you look at the pie chart here, you find issues around input supply, the retailing, the processing, logistics, and all of that. And farming in itself is just about 1/5. But when you look at the African context, most of the continent, agribusiness only accounts for a paltry 38%, and the on-farm activities is about 62%, which does not help in terms of value addition and, working up the value chain to ensure that we are able to add value to the produce and stimulate in-country resources from agriculture. Then we have the menace of climate change, and the areas most at risk to climate change is still Africa, even though it's not responsible for most of the issues that are creating the challenges, but Africa remains the most vulnerable on the planet. And when you look at this map that actually maps the vulnerability, you can see that it's only areas around the equator that is probably spared. Most of the other parts are now suffering from the impact of climate change. And the areas most impacted is the Sahelian belt from Senegal all the way to Ethiopia, and then going down to Mozambique, and then the southern belt below the equatorial region. So when you look at the vulnerability scheme of the smallholder farmers, you look at it from the top, how are the farmers exposed to these elements? So there is a likelihood of reduced precipitation because of the collapsing rain windows, increased temperature, and changes in the frequency of extreme event, flooding and drought, and all of these issues around climate variabilities. Then you look at the sensitivity, how function of production systems, communities operation, and how are these affected by climate change. And all of these come into what is known as the potential impact, where the effects of production system of social communities are impacted by the exposure and the sensitivity. And then you look at the adaptive capacity of the system, where you look at what is the ability of the ecological, economic, and the social system of communities to change and to continue to function. And then this combined into the risks of the existing system that predisposes the communities to the vulnerabilities. And therefore, productivity growth is an overarching priority, because with an increasing population, as you can see on the slide on the right, we are not able to match the food production with the demands of the population. And that actually leads us to the bottom bar chart, where Africa's net trade balance continues to increase. And this is a situation that we would like to reverse as quickly as possible. According to the African Development Bank, we were at a trade deficit of 35 billion in 2015, and that has grown to 72 billion in 2020, with a projection of 111 billion in the next 5 years. This is a statistic that we would like to reverse as quickly as possible, but we cannot reverse it just by rhetorics. We've got to use technology, and we've got to use goodwill, good governance to be able to reverse this trend. Now, because half of the world's habitable land is under agriculture, with a significant proportion under livestock farming, precision agriculture therefore presents a sustainable approach to addressing food security. So this is one takeaway package. By the same token, it's always been said that agriculture contributes a lot of the menace in climate change and climate issues. But on the other hand, I also would like to add that agriculture will provide the largest form of solutions to climate change issues. So when you look at the global land use, this is in summary what has been encapsulated there. The surface has 29% land, and 50% of this is put into agriculture. And for most smallholders in Africa, precision agriculture is all about nitrogen, the dynamics of nitrogen in the cycle in which we use nitrogen. So we look at areas with soil nutrient balances. Some are very low, especially those in the Sahelian belt, and you see the ones that are medium, high, and those with very high nutrient balances like Ethiopia, Kenya, and Malawi. and also Lesotho is recorded to be one of those with the highest. And then you can see the other side showing the extent of land degradation. This is just to show us the extent of the challenges confronting the smallholder farming system. Now, what are the opportunities for the smallholder farmers? We are in a scenario where the world is becoming a global village and there are emerging changing opportunities, as I call it. There are so many moving parts. And currently, we are in the picture you see here for livestock and crops, where there is a lot of potentials for loss. But we want to move from that into a much more organized supermarket orientation, into a market system that is much more organized, that is much more regulated, and where the profitability of the producer is known to be higher. So we need to consider the emerging trends of shifts in diets, the rise in the new markets in an emerging regional and continental markets, especially on the continent where we are now dealing with the African Free Trade, Continental Free Trade Agreement. And so these are opportunities that are on the horizon for smallholder farmers. There is also the opportunity for desert farming. And there are a lot of countries that are already tapping into this. Kenya, Ethiopia, Angola, some other countries in Southern Africa are already going into undercover agriculture, producing lots of vegetables, high-end vegetables, and cut flowers that are being used in normally desert conditions. And you can also see in the pictures here the very intensive use of solar panels because of the abundant sunshine that is being used to produce energy that is driving these production systems. There is also the question of a demand for mechanization because, as I said before, the mechanization is still at a very rudimentary level on the continent. And before we can really fast-track production, we must ensure that we take the advantage of machines. And machines give us that leverage to be able to do things in an unprecedented rate, much faster than what will happen without the use of machines. So there is a demand for labor-saving technologies, and that is rising because the demand for agricultural products is also rising. So we need to do everything we can to be able to match this demand. What are the opportunities that the youth population is also giving us? As I said before, we have a very large youth population in Africa. About 60 to 70% of the African population is considered to be young. And these are technology-savvy component of our population, which makes precision agriculture a very, very good area and attractive sector for these young folks. And so if we do what we must do correctly, we will be having an opportunity being put at the disposal of our young folks, and will keep them largely engaged in the use of IT in agriculture. So you can see in the pictures here that we're already seeing the emergence of precision agriculture in greenhouse monitoring, in irrigation, in aquaponics, in flood alert systems, and smallholder plot monitoring. So these are some of the areas where we can foray into and begin to grow the use of precision agriculture and youth involvement in agriculture. There are also other examples in using pump irrigation solution for farmers in Ghana, and then in resource smart technology in Ghana. And you also have smart applications for technology to help you grow the future. These are all AI-based alert systems that can be used to help the smallholder production systems. It also gives an impact on the impact of precision agriculture on decision support. For example, in early warning systems, we can actually predict the invasion of gregarious species like the desert locust, like incidences of flooding, incidences of drought, so that we can actually, ahead of these events, make adequate preparation to improve the resilience and the resistance of these ecological shocks, if we're able to forecast them using these precision agriculture technologies. Now I come to the subject of drones, which is also very dear to my heart, what I call drones for development. If you don't use drones to develop your systems, it's just ordinary machines, and I call them not better than toys. So drones for development are already being deployed in farming and used in geospatial mapping, deliveries, and all sorts. So you know it better than I do. But I think that drones will open up a totally different opportunity for improving productivity in our agricultural space in Africa. In the context of the fourth industrial revolution, ladies and gentlemen, I mean, there is now a totally new space of artificial intelligence and information technology by which we need to foray and break into it and take advantage of what this the fourth industrial revolution has in stock for Africa. I had already stated in many places that we are at the dawn of the fourth industrial revolution, but Africa is still yet to take full advantage of it. This is where the challenge of inclusivity is happening. And I will speak a little bit more to what this implies for Africa and the challenges that this will also bring to precision agriculture and the smallholder system. One is data. Without being able to access data, everything is futile, because without data, decision support is also not good. There is a high cost of technology, and we need to be able to provide enough resources to be able to have these technologies. We must have the human capacity, the knowledge economy to be able to deal in the context of the fourth industrial revolution. We must have overcome the demographic limitations, the issues of weak governance and poor experience on the continent. There's also an intrinsic weak capacity in the continent to deploy technologies. And you look at the issues of internet. When you see in this graph, it shows smartphone penetration in percentages and the mobile cellular subscription. We still have a very weak internet use on the continent, and this is crucial for precision agriculture and the use of the deployment of the fourth industrial revolution, so to speak. We also have a low technology adoption that leads to exclusion. As I said, the high-income countries are doing very well, but Africa is still lagging behind. And when you look at the key regions that share the shares of robots and robotics, Africa is actually not on the map. I mean, you have Asia, Australia, China dominating, but we are not on the map as Africans. That needs to change. And then we look at the investment in research and development, which is a very crucial element. And I think we need to actually invest in R&D. But unfortunately, when you look at the global situation, the countries that are investing in R&D, a lot of them are outside Africa. The African countries are still not doing what they should be doing. They should be putting 1% of GDP into R&D, but we're not seeing that as yet. Now, making precision agriculture work for me, and in closing my presentation of this morning, precision agriculture will not function without energy. And energy will also not work without precision agriculture. So for this to happen, we need to have abundant energy and the technology. So we have energy and precision agriculture. This is what will make the progress that we are looking for. Now, what do we have to put on the table as FARA? for precision agriculture. We have what we call the Science Agenda for Agriculture in Africa, which is our own tool, and it's a cardiac instrument for increasing the application of science, technology, and innovation. So we think that it is important that using precision agriculture will be one of the elements that we need to raise our human development index. And that is a crucial element for us on the continent. And we need to, dig into having the precision agriculture through the South-South Triangular Partnership. This is a picture of one of the partnerships that FARA is involved in with Indian farmers in the state of Haryana, where they use what is called the Kisan Club, and they are able to have, all sorts of land preparation, the sowing and planting technologies, the crop management, the mechanization. They are also into what is called the Uberization at the farm level. So finally, I'm closing on what the agricultural innovation system of the FARA approach is about, which is what we call the AIS. It's about having the right mix of stakeholders at the national level, cascading upwards into the sub-regional organization, into the continental organization that FARA is, and into the global organization that GFA is. And in all of this, we have the integrated agricultural research for development approach that actually pushes us in what we call the innovation to impact pathway. And I think I should be closing on this, that we do not need ripples. We've seen enough of ripples across the continent where precision agriculture is concerned. We've seen a few drones popping up here and there. Where you need a tsunami, ripples do not help. In order to be able to make significant impact, we do need to have a tsunami of technologies, of precision agriculture, and the like, to be able to meet the demands that we're looking for. Thank you very much, and all the best for the Conference on African Conference on Precision Agriculture.